Hey, this is the 8th episode of Automat DEVLOG. Today we are going to conclude the assembler project. If we take a step back, the end goal of Automat is to create a new computing environment, something where instead of clicking on buttons within apps, the apps can be connected. It's possible today. We want to make it possible for people without programming experience. This should be the default mode of using computer. The apps should just be connectable. This is a very ambitious goal. We are going against a long history of applications that dates back to 70s. It will be very hard to create a compelling general purpose environment from the get-go. So it's better if we pick a more reasonable short-term goal. This short-term goal is a decent environment for game automation. This is something that I think is missing. There are some tools for game automation, but I think we can create something better here. So this is what we are doing. This is what Automat attempts to do this year. The whole of 2025 we will spend working towards this game automation environment. This is the context in which we should see the assembler project. The point of the assembler project was to fill the gaps in the Automat's very linear execution model, and this is how we should evaluate it. So today let's take a look at how the project went. The past 2 months that we've spent working on the assembler. First of all, what did work? We managed to implement something that can actually be used to create loops. So here we have an example of a loop where we set a register to 10 and then every second we subtract 1. We can see this being executed, where we are executing those small loops 10 times, and then we are resetting the register back to 10, and again executing these 10 times. This is just one way to do a loop. There are many different approaches for doing loops, like with different registers using different instructions. The choice of x86, looking back, it seems that it was a good choice. Alternative would be to create a custom instruction set or use an existing, something like JVM or the Python VM or the Mu VM, many instruction sets to choose from. x86, contrary to popular belief, is relatively simple. There are a couple quirky constructs there, but once you get to know how they work, it's surprisingly regular. This instruction set has very good compatibility with existing tools. So when I was debugging issues with x86 assembly machine code generation, I used regular decompilers. I was just copying the hexadecimal machine code, putting it into the compilers, and it was really helpful to use existing tools to develop this project. And also the performance is just incredible. Here I have an example. First, I will set the CX register to 32. This is the actually simplest way of doing this without editing any files. So when I executed this piece of code, it actually filled the CX register with this value. Now with that, I can actually execute other piece of machine code, which is reading current time and storing it in BX, in the box register. When we look at the state of registers, we can see that, hey, this is current time, pretty much. Those are seconds, those are fractions of seconds. It executes kind of fast. There are other benchmarks we could do here, but I'm really happy with how efficient the assembly execution is. Next, the choice of LLVM. I think it was also a good choice. We could have picked different assemblers. There are many assembly libraries on GitHub that we could pick. Assembly in LLVM is not so straightforward, so it was a little bit of an uphill battle, but I think now that we have LLVM, we got access to nice data structures that we can now use. And it also allows us to use other LLVM tooling. If we want to embed a C++ compiler in the future, it's not going to be as hard. The UI components, they proved to work very well for this project. We have a nice, very natural, very intuitive to use interface for working with instructions. They are grouped in those categories. It's, at least for me, maybe I'm the wrong person to ask, but for me it became very easy to navigate this tree of instructions. I always know where to find the pieces that I'm looking for. Those filters we could improve, but the point here is that the UI components that we have within Automat, they worked very well. They allowed me to build this fairly quickly without many any issues. Another interesting point was that usually when we program something, there are those time sinks. There are those very small problems that in the end, they turn out taking most of the time. In the case of assembly, it seems like this was not the case. It seems like everything went fairly smoothly. The work was fairly linear, I would say. Now, let's talk about the things that didn't work that well. When I initially was starting this project, I was hoping that we will be able to have many more control flow primitives, like the ability to schedule stuff in parallel because Automat is intrinsically parallel, or the ability to create more complex conditions to wait on other objects. This is still not there. It's not impossible to implement it, we just need a couple more instructions, a couple extra objects here that would allow us to implement those missing functionalities. But we have to admit, those things are still not here. And when it comes to the assembler environment itself, many pieces which we wanted to have are still not there. So it only works on Linux, which is a bummer. We don't have some things which we wanted to have in the instruction selector, like selecting the size of the operation. The instructions, they don't have fancy diagrams. We wanted to have much nicer diagrams instead of saying, just in English, set AX to AX or something. Here we wanted to actually have nice diagrams which would explain how this logical operation works. And also flags. We don't really have flags. There are some pieces of flags. Yeah, this is the, I think, sign flag or carry flag. I don't remember. Another bit of functionality that we didn't have time to implement. We also don't have step-by-step execution. So this assembler, when we run something, it just runs in a loop at full speed. So it takes 100% of the CPU all the time until we pause it and then it stops. And also we wanted to better organize instructions. We really wanted to have tapes so that sequences of instructions can be nicely compacted. Still, if we summarize this, I think we got out of the assembler project as much as we could. I think this is a good point to switch back to developing the core of Automat, the game automation application. What's next on our plate? We are going to do a lot of bug fixing, and we will have to implement a lot of smaller usability features within Automat, like the ability to select multiple objects at the same time, the ability to tweak length of the segments on the timeline, things that I usually have to do by hand by editing the save file. All of them should be doable from within the UX. We will be also testing it a lot more by playing games. This will come soon. Okay, I guess that's it for the 8th episode. See you next week. Bye.